It's imperative that hazards associated with gas extraction, processing, transportation, storage, and consumption are identified and controls put in place to reduce the risk of injury or harm to personnel, equipment, or the environment. Major hazards associated with gas extraction are chemicals used at the gas wellheads during operation, injuries from the use of rotating equipment, musculoskeletal damage associated with heavy lifting, for example drill pipes, escape of gas from the wellhead. Major hazards associated with gas processing are rupture of high pressure piping, venomous snakes, spiders and other dangerous animals on site, asphyxiation due to gas leaks in enclosed areas without ignition, fire or explosion due to gas leak ignition. Major hazards associated with gas transportation are collision with bridges, cryogenic burns due to low temperatures, cryogenic damage to ships from very cold LNG, explosions in confined spaces, either combustion events or events of rapid phase transition. Major hazards associated with gas transmission are slow leaks due to corrosional holes in the gas pipeline, buried gas pipeline ruptures due to excavation, ruptures of surface pipelines from vehicle collision, pipeline ruptures as a result of natural disasters, fatigue from driving during inspection of the pipeline easement to observe factors that impact safe operation. Major hazards associated with LNG gas storage are cryogenic burns due to low temperatures, gas leaks which are difficult to detect due to gas being odourless. Note that cryogenic temperatures make it extremely difficult or impossible to add odorants. Change in physical characteristics of the gas over an extensive period of time without withdrawal, brittle fractures due to low temperatures. Major hazards associated with underground gas storage are jet fire due to leaks in the link line, which is the pipeline that connects the compressor station on the surface to the depleted gas field below the surface, leaks due to corrosion of the pipeline, dangerous wildlife such as snakes and spiders, natural disasters such as an earthquake, high-pressure pipeline ruptures. Major hazards associated with gas consumption in residential areas are carbon monoxide poisoning due to incomplete combustion, asphyxiation from gas leaks into enclosed areas without ignition, fire and explosion due to gas leaks into enclosed areas with ignition. Major hazards associated with industrial customers are fire and explosion due to gas leaks with ignition, asphyxiation due to gas leaks in a confined space without an ignition source, dangerous wildlife such as snakes and spiders, equipment failure due to out-of-spec gas. Fire is the biggest hazard associated with handling natural gas, and so it's important to understand the factors that result in gas ignition. While the fire triangle may be well known, it's important to understand how it applies specifically to natural gas. Methane requires oxygen to burn. If the concentration of methane in air is greater than 15%, there is not enough oxygen for it to burn. On the other hand, if it is less than 5%, the gas mixture is too dilute to burn. These limits are known as the upper and lower explosive limits. Heat is another crucial factor in combustion. The anti-ignition point for methane is 580 degrees Celsius. This is the minimum temperature required for methane gas to ignite in air without a spark or flame being present. Fuel is the key element of combustion. Methane is primarily used as a fuel, and if the concentration of methane is higher than 15%, the mixture is too rich to burn. Therefore, a spark inside the pipeline will not start an explosion. When there is between 5 and 15% of methane in the air, the mixture is flammable. The mixture can either auto-ignite at temperatures higher than 580 degrees Celsius or ignite by a spark. The spark could be from someone smoking, a car engine, or even the static electricity of nylon clothing. After understanding how a fire can start, it is important to understand the different fire types. When natural gas is ignited, it forms either a jet fire or a flash fire. A jet fire occurs when a flammable liquid or gas is ignited after its release from a pressurized punctured vessel or pipe. The pressure of release generates a long flame which is stable under most conditions. A flash fire can take the form of a jet fire on reaching the spill point. A flash fire occurs when a cloud of flammable gas and air are ignited. Within seconds of ignition, the flame spreads both upwind and downwind of the ignition source. The flame is contained within the cloud due to the premixed burning of the regions within the flammable limits. The gas industry is one of the most hazardous industry sectors, which makes safety the number one priority. Some of the common hazards in this industry are highlighted in this example. High voltage can cause serious injury, burns, and even death. High voltage equipment has exclusion zones for your safety. Arc flash is one of the biggest hazards and can be caused by dropping tools on live areas, pests causing short circuits, switching, or accumulation of dust and moisture. Falling from a height can result in serious injury or fatality. Obtaining an exhaust stack measurement may require working from a height. Australian legislation considers the risk of falling 2 or more metres as a high-risk activity and mandates the use of both SWMS and fall protection during this activity. Natural gas is flammable and safety compromises could result in a catastrophe. There are a variety of methods that can detect natural gas pipeline leaks, ranging from manual inspections using gas sniffers to advanced satellite-based hyperspectral imaging. It is extremely important to follow safety guidelines when performing high-risk activities that could result in ignition. Confined space activities can cause fatality from asphyxiation. Identify if a confined space permit is required prior to undertaking work and plan ahead, as confined space entry will require a specific permit, appropriate training, and additional protective measures. Excessive exposure to loud noise can lead to loss of hearing and ongoing health issues. Health guidelines recommend limiting continual exposure to below 85 decibels. A gas turbine operates in excess of 115 decibels. Always wear dual-layer hearing protection, earplugs and earmuffs when you are near one.